In this video, we will talk about how to solve proportions. So I have 4 examples for us to work through here. Let's check out the first example. Let's say we have 5 over 7 is equal to 20 over x, and we want to figure out what is x. So there are 2 methods that you can use to solve proportions. The first is identify a multiplication or a division relationship, and the second method is use cross multiplication. So when I'm working on these types of problems, I always start with the first method. I try to see if there's a multiplication or a division relationship. So what I mean by that is when we have 2 values that are both in the numerator or 2 values both in the denominator, we want to ask ourselves, is it possible to take one value and either multiply it or divide it by some value to get this other value? So in other words, can we multiply 5 by something to get 20? Yeah, we can multiply 5 by 4 to get 20. So 5 times 4 is 20. So that means this first method, this worked out. So we're going to use this method 1. So what that tells us is if we multiply this 5 by 4, we need to multiply this 7 by 4 as well to get this denominator. So what is 7 times 4? That's 28. So x must be equal to 28. And that's our final answer. And what we'll find is if we write a 28 right here, we'll find that 5/7 is equal to 20 over 28. These are equivalent fractions. Or in other words, they have the same value. Okay, let's try another example. Let's say we have 6 over 3 is equal to x over 11. We want to figure out what x is. So once again, we'll start with the first method. Can we identify a multiplication or division relationship? So since both of the denominators already exist right here, we'll look at the denominators. And we'll say, is there a number that we can multiply 3 by to get 11? No, there's not a whole number that we could multiply it by. So it looks like this first method is not going to work. So let's try the second method, cross multiplication. So that's when we multiply the values that are diagonal from each other and we set them equal to each other. So we say 6 times 11, that's 66. We set it equal to 3 times x, which is just 3x. Now to solve for x, we just need to divide both sides by 3. So when we do that, the 3's cancel out on this side, and 66 divided by 3, that turns out to be 22. So x is equal to 22. And that's our final answer. And what we'll find is 6 over 3 is equal to 22 over 11. All right, let's try another example. We have x over 4 is equal to 24 over 32. So to solve for x, we're going to try our first method here. Can we identify a multiplication or division relationship? Well, we can ask ourselves, to go from 4 to 32, is there a number we can multiply by? Yeah, we can multiply by 8. So we could say 4 times 8. Or another way to think about it is, if we do 32 divided by 8, we can get 4. So if we say 32 divided by 8, we get 4. So if we perform this division in the denominators, we can also perform this division in the numerators. So let's say 24 divided by 8, what would that be? 24 divided by 8 is 3. So x must be equal to 3. And that's our final answer. So in this case, the method 1 worked, so we don't have to use cross multiplication. And what we'll find is, if we plug in a 3 right here, 3/4 is equal to 24 over 32. So these 2 fractions have the same value. All right, let's try one more example. Let's say we have 6 over x is equal to 4 over 10, and we want to solve for x. So we'll try the first method. Let's see if we can find a multiplication or division relationship. So since both values already exist in the numerators, we'll focus on the numerators. So is there a value that we can multiply 6 by or divide 6 by to get 4? Well, it turns out there is not a whole number that we can multiply or divide by to get 4. So we'll cross that out, and we'll try the second method, cross multiplication. So remember, that's when we multiply the values that are diagonal from each other and set them equal to each other. So 6 times 10, that's 60. And we'll set that equal to 4 times x. So 4x. Now to solve for x, we just need to divide both sides by 4. Over here, the 4's will cancel out, and we'll be left with x is equal to 60 divided by 4. That turns out to be 15. So here's our final answer. X is equal to 15. And we'll find that if we plug in a 15 here, 6 over 15 is indeed equal to 4 over 10. And if we were to simplify both of these fractions, so if we divided the numerator and denominator of this one by 3, we would end up with, I'll write it over here, 2/5. And if we divided the numerator and denominator of this fraction by 2, we would end up with 2/5. So we would find that they're both equal to each other. So that's how we can verify that x is equal to 15 is the correct answer.